Is there life beyond Earth in our solar system? Wow, what a powerful question. You know, as a scientist, planetary scientist, we really didn't take that very seriously until recently. You know, Carl Sagan always said, it takes extraordinary evidence for extraordinary claims. And the claims of having life beyond Earth need to be definitive, they need to be loud, and they need to be everywhere for us to be able to believe it. So, how do we make this journey? What we decided to do is first look for those ingredients for life. The ingredients of life are liquid water. We have to have a solvent. Can't be ice, has to be liquid. We also have to have energy. We also have to have organic material, things that make us up, but also things that we need to consume. So we have to have these elements in environments for long periods of time for us to be able to be confident that life, in that moment when it starts, can spark and then grow and evolve. Well, I have to tell you that early in my career, when we look at those three elements, I didn't believe that they were beyond Earth in any length of time and for any real quantity. Why? We look at the inner planets. Venus is way too hot. It's got no water. Mars, dry and arid. It's got no water. And beyond Mars, the water in the solar system is all frozen. But recent observations have changed all that. It's now turning our attention to the right places for us to take a deeper look and really start to answer our life question. So, when we look out into the solar system, where are the possibilities? We're concentrating our attention on 4 locations. The planet Mars, and then 3 moons of the outer planets, Titan, Europa, and small Enceladus. So what about Mars? Let's go through the evidence. Well, Mars, we thought, was initially moon-like, full of craters, arid, and a dead world. And so about 15 years ago, we started a series of missions to go to Mars and see if water existed on Mars in its past that changed its geology. We ought to be able to notice that. And indeed, we started to be surprised right away. Our higher resolution images show deltas and river valleys and gullies that were there in the past. And in fact, Curiosity, which has been roving on the surface now for about 3 years, has really shown us that it's sitting in an ancient riverbed where water flowed rapidly, and not for a little while, perhaps hundreds of millions of years. And if everything was there, including organics, perhaps life had started. Curiosity is also drilled in that red soil and brought up other material. And we were really excited when we saw that, because it wasn't red Mars, it was gray material. It's gray Mars. We brought it into the rover, we tasted it, and guess what? We tasted organics, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. They were all there. So Mars, in its past, with a lot of water, perhaps plenty of time, could have had life, could have had that spark, could have grown. And is that life still there? We don't know that. But a few years ago, we started to look at a number of craters. During the summer, dark lines would appear down the sides of these craters. The more we looked, and the more craters we saw, the more these features. We now know more than a dozen of them. A few months ago, the fairy tale came true. We announced to the world that we know what these streaks are. It's liquid water. These craters are weeping during the summer. Liquid water is flowing down these craters. So what are we going to do now that we see the water? Well, it tells us that Mars has all the ingredients necessary for life. In its past, it had perhaps 2/3 of its northern hemisphere, there was an ocean. It has weeping water right now, liquid water on its surface. It has organics. It has all the right conditions. So what are we going to do next? We're going to launch a series of missions to begin that search for life on Mars. It now is more appealing than ever before. As we move out into the solar system, here's the tiny moon Enceladus. You know, this is not in what we call the traditional habitable zone, this area around the sun. This is much further out. This object should be ice over a silicate core. But what did we find? Cassini was there since 2006, and after a couple years, looked back after it flew by Enceladus and surprised us all. Enceladus is blasting sheets of water out into the solar system and sloshing back down onto the moon. What a fabulous environment. Cassini, just a few months ago, also flew through the plume, and it measured silicate particles. Where does the silica come from? It must come from the ocean floor. The tidal energy that's generated by Saturn, pulling and squeezing this moon, is melting that ice, creating an ocean. But it's also doing that to the core. Now, the only thing that we can think of that does that here on Earth, as an analogy, are hydrothermal vents. Now, hydrothermal vents deep in our ocean was discovered in 1977. Oceanographers were completely surprised. And now there's thousands of these below the ocean. What do we find? The oceanographers, when they go and look at these hydrothermal vents, they're teeming with life, regardless of whether the water is acidic or alkaline. Doesn't matter. So hydrothermal vents are a fabulous abode for life here on Earth. So what about Enceladus? Well, we believe because it has water and has had it for a significant period of time, and we believe it has hydrothermal vents with perhaps the right organic material, it is a place where life could exist, and not just microbial, maybe more complex, because it's had time to evolve. Another moon, very similar, is Europa. Galileo visited the Jupiter system in 1996 and made fabulous observations of Europa. Now, Europa, we also know, has an under the ice crust ocean. Galileo mission told us that. But we never saw any plumes. But we didn't look for them. Hubble, just a couple years ago, observing Europa, saw plumes of water spraying from the cracks in the southern hemisphere, just exactly like Enceladus. These moons, which are not in what we call a traditional habitable zone, that are out in the solar system, have liquid water. And if there's organics there, there may be life. This is a fabulous set of discoveries, because these moons have been in this environment like that for billions of years. Life started here on Earth, we believe, after about the first 500 million. And look where we are. These moons are fabulous moons. Another moon that we're looking at is Titan. Titan is a huge moon of Saturn. It perhaps is much larger than the planet Mercury. It has an extensive atmosphere. It's so extensive, and it's mostly nitrogen with a little methane and ethane, that you have to peer through it with radar. And on the surface, Cassini has found liquid. We see lakes, actually almost the size of our Black Sea in some places. And this area is not liquid water, it's methane. If there's any place in the solar system where life is not like us, where the substitute of water is another solvent, and it could be methane, it could be Titan. Well, is there life beyond Earth in the solar system? We don't know yet, but we're hot on the pursuit. The data that we're receiving is really exciting and telling us, forcing us to think about this in new and exciting ways. I believe we're on the right track, that in the next 10 years, we will answer that question. And if we answer it, and it's positive, then life is everywhere in the solar system. Just think about that. We may not be alone. Thank you.